Welcome back to Everything's a Project. I finished up that one adapter piece. So this is 803 thou. This is what we did on the 4-jaw chuck. There's a similar piece getting ready to do, so I'm going to show you that process and probably threading on the hard hinge. The other piece is going to mate to this. I did this on the hard hinge. It's a 1" 20 thread. Originally all this is metric, but instead of I don't have the metric threading capabilities on the hard hinge, so we went to SAE thread since I'm making all the pieces that go together. So a lot of this is still set up from before. So we'll just go over some of that. So the part's down in there in the chuck. Use a V-block just to get a little better hold on the part. Use parallels not only to bring it up, but also to where it's positioned keeps it from wanting to flip. Okay, so we'll indicate it in. So again, I love having this, what started off as a ejector pin, 1/4" ejector pin. It just gives you so much better feel and adjustability. Takes a lot less effort to fine tune your sweep. There's always a chance of it bumping into something, but once you get used to using it, it's not a major thing. So again, first thing you do is get your stylus over the top of your workpiece, spin it. That gives you an idea where you are. So we're pretty far off, so we need to go move the table that way. Okay, so that looks pretty good sweeping without touching the part. Now we'll make contact with the part. Again, using this, just influence inboard to make contact. Much. I like to try to get about half a sweep, the sweep of the needle of contact. That way I don't have to worry about multiple revolutions, and if it really starts to go out, I adjust on the fly. Like that's really far out. So yeah, so now it's less than half a sweep out. So that's pretty far that way. Oops, went the totally wrong axis. Try this again. don't know if you can see it. Let's see. Trying to look in the viewfinder. See those 3 black lines on the one side of the indicator, and then the other side doesn't have any markings? That helps you to keep track of if you're touching heavy or light on the part. So as I was indicating the part in, the needle was going towards the black lines. So it's hitting heavier, so now I need to bring it back. So we need to readjust 0, so you can either do it on the, well, in this case, just do it by adjusting the dial, or the face, I mean. So that's 15 thou heavier on that side. So split the difference. So on your first axis, the Y, split the difference. Re-0. Recheck. So now it's thou and a half, the opposite direction. So try to get 7/10. Split the difference. Come back. Recheck. I think it's going to be within a half. 1. That's more than enough. That's plenty close enough for this initial sweep, because now we have to adjust. Actually, yeah. So now we have to adjust X. It's almost a whole rotation of the needle off. So that was going towards the white area. So we want to try to get to the same 0 as the Y. So X was off so much that it threw off the Y by almost a whole sweep. So that we still split in half. So these are 30,000 sweeps. So I adjusted 15 thou. So X is off 14 thou. Y is back to 0, 0. So now we bring the needle back to 0 for the X axis. And now the needle is pretty close. It's off a little bit. That one more time. Again, using an edge finder beforehand is often helpful. But if you can get proficient with just the indicator, eventually you'll save time. This is actually taking longer than the first one. of course, because this is the one that's on video. But this is what you gotta do. Okay, so the sweep is all within a half a thou, which is plenty good. And what's interesting is, with all that work, it still ended up within 2 thou of the first piece that I did, according to the DRO. Sorry about my arm. Let's get this. Okay. So then, I don't like to keep moving the table on this stuff. I'd rather move the Z if I have to change tools and that, so I want to lock the table down. Table deviated a thou. I only like half a thou. Aim small, miss small concept. Okay. I don't want to keep going in front of the camera if I don't have to, but yeah, I don't want this in the way. So I just clamp mine to the arm of the DRO. So it's handy, but out of the line of chips. So actually, none of what I'm doing needs a center drill. I can go right to the stub, the screw length drills. If it needed to be a little more precise, then a center drill would be nice, but I can save that step in this case. Okay, so let me just check the offset. Offset is 197 thousandths. I like to do all that in X. I prefer to move X more than Y. I'll keep Y locked down as long as I can. I'll have to move it in a moment when I do the bolt pattern. So 197 thousandths offset. Phase converters on. Put in a drill, of course. So this is a 1/4 inch drill. This is what I use for the pilot hole when I set up on the 4-jaw chuck. It's in back gear. Can't remember what I did in back gear. Forward gear, beautiful, smooth, E-head, spinning 800 RPM, 830. Gonna make a nice clean hole. Tell you what, I like this much better than the old original Bridgeport heads. They don't like as much RPM. Definitely not as smooth. Put a little dab of Dooya in there. Sure, I could go even more RPM. I like to be conservative with my cutting tools. 1/4 inch is a go-to for a lot of starts, and I get thousands of holes off of these, off of a good centered screw length drill without messing around with it. You know, I've done it here, I've done it at home, or at work, I mean, and I don't want to smoke them. There's not enough time savings. So that's all we have to do with that hole. And now we're going to do the bolt pattern. And converted to metric, it's 200, or from metric is 276 thousandths. I forgot my chart, but what was that? So it's a letter J drill. And this is the same pattern as that first piece. So I had already put in the bolt circle information. So, let's see, so I'll go over that real quick. Okay, so bolt use. Start with bolt use number 1. Okay, now it'll go to the move I have to make. So Y stays. And we just move in X till DRO reads 0. You work it back to 0. Fire it up, plunge the hole. I like to put my finger on the opposite side, not to hold it in place, but to just feel if something's unloading and might compromise the part. So now with this DRO, you just hit bolt use again and it goes to the next one automatically. And so now we're moving X and Y both until they get to 0. Just want to make sure you guys aren't looking at my bald spots and my bed head or whatever. You know, the beauty of working in the home shop. Okay, DRO's on 00. Love these cheap chip brushes or paint brushes. They're used to be $1. They probably crept up a little bit. So just flick the chips out of your way. You know, I don't like to use the blow gun a lot because, you know, it puts chips in places they shouldn't be. You have to run your air compressor. So I slid the parallel out of the way so I don't bop it, but it's still doing its job, keeping the part up and keeping it from tilting. So now we go to bolt 3. So I had to finally break down and turn the heat on. So Phoenix, you know, we had a hot summer and everybody lost their minds over it. But we had 18 months of, prior to that, of the most moderate temperatures I've seen in 20 years here. So we've had some cool mornings in the 40s. And then yesterday on the news, they were all getting out of shape. Oh, the hot summer's continued into the winter. It's going to be 78 degrees during the day. Well, everybody that's talking about saving energy and all that stuff, if you have moderate temperatures, like a little warmer than normal in the winter, you're using less energy. I think a lot of these people don't have rationale. They just go from one extreme to the other. Oh, it's a degree warmer, we're all going to die. It's a degree cooler, we're all going to freeze to death. Well, it all averages out. If the Earth really did have its hottest year ever by 10 degrees, we'd all be dead because we'd have to take in so much more energy from the sun for that to happen. And what these numbnuts never think about is what other factors there are. And one of them is that the sun, I guess, has a 11-year cycle of somewhat. So we determined there's an 11-year cycle with 100 years worth of data. But anyways, it's at the end of that. So it has an anomaly where it gets a cold spot on the sun, but then that relates into throwing more energy towards our direction. And it's got a lot to do with magnetism and stuff, so that influences weather patterns, you know, everything with magnets. It influences how much energy comes our way so much that Starlink lost, I forgot, it was like 200 or 300 of their satellites, or like mini satellites, because one of the boundary layers that we have between us and space expanded so much that the propulsion motors on those little satellites didn't have enough juice to cross that expanse. So say it was normally 3 miles expanse it had to go across, it was like 30 miles. So tell me we got control over something that can change how much the boundary layer moves. You know, we don't. And taxes aren't going to make a difference either. So there's the rant on that. Reduce, reuse, recycle, improve. Not taxes. Not electric cars. I'm a first day investor in Tesla. Electric cars are not the solution. Tesla was the solution. The U.S. government, who got $8 billion for electric car chargers and didn't install one yet in 2 years. Tesla put in thousands of them with their own dime. That stuff needs to run its course. As it trickles down, you know, people that can afford to have an electric car, have multiple cars in case the electric doesn't do what they want, then it needs to trickle down. You don't need a bunch of these idiots that are blind to everything, making decisions that cost you and I tens of thousands of dollars next time we go to buy a car. But you also don't need to be rolling coal all the time either. We should be able to afford inexpensive cars that we can commute to work, and then have a truck that sits in the driveway till we need a truck, have an SUV that sits around until we need to take the whole family. We don't need to have all of our ducks or all of our eggs in one basket of driving a 6,500 pound SUV back and forth to work with you the only one in there. Cars have trunks. I can put a whole shitload of stuff in my little car's trunk, and I have. Okay, so now we're going to move over to the lathe, and I'm going to try, you know what, I'm going to pause the video and I'm going to get a better view, because last time unfortunately I completely blocked it here. So see you in a little while.